If you are still using tubular batteries or lead acid batteries in 2025, you are wrong. Now, in this video, I'm going to show you how to properly size a solar system that is perfect for your home loads in 2025 using lithium batteries, high efficiency solar panels, and hybrid inverters. Now, emphasis on lithium batteries, high efficiency solar panels like the 550 watts and above. They are mostly half-cut panels. Half-cut panels. Lithium batteries, then hybrid inverters. These are the future of solar energy systems. When you want to do a solar system that will last you, that will give you the best performance for your loads, you need to be looking towards this kind of system. Now, a hybrid inverter, how does it differ from a normal inverter? A hybrid inverter is the type of inverter that has a controller inside. So when you buy the inverter, you don't need to buy an extra controller, charge controller, to be able to charge your batteries. Now, they are well suited to work with these kind of sets of lithium batteries and big high efficiency solar panels. It's very easy to install. The idle state current consumption is very low. Now, let's go straight to the topic of today. Now, you need to understand that for solar systems, the loads that you are going to be using, if you plan to use solar system in your house, you need to understand that there are loads that are solar friendly and there are loads that are not supposed to be used for solar systems if you want your system to last longer. I'm going to tell you, number one, for the lights, if you want to use solar system, you should be looking at LED bulbs. LED bulbs. And not the normal kind of bulb, the incandescent bulb, that yellow bright bulb, that is 60 watts, 100 watts. That one is very high consuming load. 100 watts is a lot of load for solar systems. Now, for LED bulbs, there are LED bulbs of 3 watts, 6 watts, 10 watts at most. You should have 10 watts as the highest bulb that you will be using for your solar system. You need to know that the energy you get from the solar system as AC, it's being converted from chemical energy from the batteries to electrical energy. And so that conversion process doesn't need you to be using a lot of loads per time on the batteries. Then that's for bulbs. Then for fan, if you have plans to use fan for your solar system, you need to first of all bought ceiling fan. Anything relating to ceiling fan is a no-no. Now you need to be looking at table fans, small solar sized fans. There are some solar fans. There are even some fans that come with solar panel. You can use an adapter to power the fan. They are called solar DC fan. When you go to the market, just let them know you want to get a solar DC fan. Then they will give you a lot of options. There are some that come with solar panels. Most of the time, they use a DC adapter to get power. Some of them even have inbuilt batteries so that you can charge the fan, and when there's no light, you can use the batteries instead of using light directly. So you should be going for solar fans. Then for lights, LED bulbs. Then for fans, solar fans. Then also, anything relating to loads, you need to be looking at the ones that consume less power. Now, if you have plans to use AC, we have normal AC and we have the inverter AC. So you should be looking at inverter AC. Now, when you have all this in mind and when you have all this settled, then you can now proceed to the next step. Now, the next step is knowing the power rating of each of your loads. The power rating. And when you know the power rating of each of your loads, you need to also know the amount of time per day or the amount of hours per day that you're going to be using those loads. Now, if I have a bulb and I have a fan, my consumption, it's totally different from what somebody else that has the same load will consume. Even if we have the same load, two persons can have the same load and different consumption because of the time. I can decide to use my bulb for just 2 hours and my fan for 1 hour. Then the next person can use bulb for 8 hours and also the fan for like 6 hours. So our load demand differs. And lastly, before I forget, for TV, you should be looking at LED TVs, not the plasma TV or the cathode ray tube, the one that has a long protrusion at the back. TV, LED TVs. Then also refrigerator. We have these recent refrigerators, there are inverter refrigerators. You go to the market, you can find them in the market. The power consumption is not more than 200 watts for a deep freezer that works so well. Not those old kind of refrigerator, those Belgium one that you normally buy at second hand. No, those ones are not solar friendly at all. They consume large amounts of power. Now let's go to knowing the loads and the power rating of each of your loads, and also the amount of time that you're going to be using those loads. These are the loads that we have in our home. I want to size the solar system for these loads. We have a refrigerator, we have TV, we have lights, we have fan, we have router, then we have the CCTV, and also I put a question mark for AC and borehole. I'm going to explain the reason. Now, for your refrigerator, I'm going to explain this table quick. This is your load. Then we have the power rating for your loads. Then we have the hours per day, the number of hours that you reach or that you tend to use these loads per day. Because there are loads that you don't need to put on 24 hours. There are loads that you need them to just be on for 2 hours, depending on just what you want. Then we have energy. The energy or the daily consumption, it's the power times the number of hours. The power rating of the load times the number of hours that you are going to put it on. So when you multiply them together, you have the energy consumption or the daily energy consumption for that particular load. Then if you name this one A, this B. So this table is A times B. Now I'll explain. Your refrigerator, assuming you have two refrigerators, one in the parlor, and maybe the normal standard refrigerator and a deep freezer. Let's assume that both of them have 100 watts of load. Now you multiply 2 times 100 to get 200 watts. Your refrigerator, the total number of refrigerators you have in your house will consume 200 watts. Now to get the power rating of your appliances, most times it's written at the back behind the appliance. You check the nameplate. There's a sticker where you can see these values: watts, current rating, and the voltage. Sometimes you might not even see it as watts. You can see the voltage and the current in amps. All you need to do is for you to multiply voltage and current to get the power. Because power is equal to voltage times current. But most times you find it in watts. Now, this 2 times 100 equals to 200. Now, 200 times 10 is 2000. We are going to switch on our refrigerator for 10 hours. Then we consume 2000 watts of energy. 2000 watts of energy for that particular day. The TV, you have three TVs, multiply by 60 watts each. The left TV most times is 60 watts, 70 watts. You have 180 watts. So you multiply by 6 to get this. The light, let's say you have 12 lights in your house in total. If you have more than 12 lights, you multiply by the watts of the lights. Let's say 5 watts. You have 12, 60 times 12, 720. Also for the fans, I'm using DC fan. If you're having a ceiling fan, you might be having up to 100 watts, 80 watts. So I'm using DC fan, and so the wattage is around 15 watts, 12 watts. Multiply by 18 hours of usage, you have 1080 watt hour. Then you have the router. Most times it's 24 hours. You don't want internet to go up in your house. You have a router. 12 times 24, you have 288. The power rating so is not so much. You check the adapter, the power adapter, because most times on these equipment they have power adapters that convert AC to DC. So when you check the output in DC, you see the current rating and also the voltage. Most times it's 12 volts times about 2 amps. So 2 times 12 is 24. Most times, sometimes it's 12 volts and 1 amp. So 12 times 1 is 12. So you have 12 times 24 hours, you have 288. Then your CCTV is 247. If you have CCTV in your home, multiply by 24 hours, 480 watt hour. Now, let's go to your inverter sizing. That's the first thing we need to do. How to size your inverter. Now, what you need to know is the peak load. What is your peak load? Your peak load is the total amount of power that all your loads will consume at the same time when they are switched on. If you switch on all your refrigerators, all your TVs, your lights, your fan, your router, and CCTV, you want a situation whereby if all your loads are on, there's enough space for your inverter to be able to power everything without stress, without overload. So that's your peak load. Now the peak load is the sum total of all the wattage, the individual wattage of every load that you have here. So when you sum everything together, you have 532 watts in total. So this is your peak load. So with the peak load, you have an idea of the size of inverter that can power all these things. Now, mind you, The fact that you have 532 watts here doesn't mean that you need just a little above 532 for the size of your inverter to be able to power your load. Now, there's one thing you need to know at this point. When it comes to sizing inverters for load, now we have what we call generator versus load. Is one principle that I normally use. We have the generators, we have the loads. Now, for the generators, when you are sizing the generator is the device that produces the power for your load. When you're sizing generators, you need to underestimate the size of the generator. So when you have 5 kilowatts, your generator is 5 kilowatts or 5 kVA, just take it as 3 kVA because of losses. Then for your load, overestimate the size of your load. So if you have 532 watts as your total load, just make it 1000 watts because there are no losses in load. You only have losses in your generator, the source that provides power for the load. And so, even when you want to consider future addition of load, more load in the future, you may want to add a microwave later, you might decide to buy 3 extra fans. So you need to create space, to create room for the future load that you will add, and also consider the inverter's efficiency. Now, most times these inverters they have efficiency value 80%, 90%, 70%. So that's actually the reason why you have to estimate the power of your inverter. So when you put all those into consideration, these are peak load, but let's make this 3.5 kVA, or let's just make it 5 kVA. If you want to add more load, depending on the kind of load you want to add. If you want to add AC later in the future, then you can make it 5 kVA system. If you want to just add maybe extra refrigerator, 2 fans, 3.5 kVA. And let's assume you are going to add an AC in the future. I want to make this system a 5 kVA system. So 5 kVA system. Now 5 kVA, most 5 kVAs they come in 48 volts. Now we are going to treat this one in another turn, in a different topic. You can also use 3.5 kVA, you can use 4 kVA, depending on the amount of flow that you wish to add in the future. So that's it for that. Then also, the most important part of sizing of solar system is the battery, because the battery is what determines whether your solar system is working or not. If you have poor backup, then it's going to tell on the entire system. Your batteries and your panels have to be very good. You have to do the best job. Even if you can have 10 kVA inverter, and if your battery is not enough to power the load, that system is a failure. If you have the highest inverters, the most sophisticated inverter, and you don't have the right backup to power the loads, and also the panels to charge the batteries, then that's not a working system. The system can be described as not working. So you already know how to size the inverter. It depends on you. If you want to go for 2 kVA, you can go for 2 kVA because you have 532 watts as your peak load. So why not? 2 kVA can work. It's only in an ideal situation where you have to switch on all the loads. Most times you just switch on maybe 1 or 2. But I'm strictly using low power consuming loads. Some persons, they don't have this kind of load. They have fans, ceiling fans that consume up to 50 watts, 60 watts. So the calculation, the table, your table is going to be different, quite different. You get the point. So that is it for that. Okay, so let's move over to the battery calculation. Now, this part of the table, this column, is important for us to determine the inverter size. The why this part of the table, this column, is important for us to determine the battery size, which is the most important part of this class. Now, let's go to the battery size. Okay, before I forget, let's talk about this AC and borehole. When you have your AC, there's one thing. ACs are mostly rated in horsepower. You can have 1 horsepower, you can have 1.5 horsepower, and you have 2 horsepower. Now, when you have your AC, you need to know how to convert horsepower to watts. Now, there's a conversion factor for that. 1 horsepower is equal to 746 watts. So if you have 1 horsepower AC, then you just know that the amount of watts is 746 watts. For your AC, there's what we call starting power and running power. There are two different things. Now, this 746 watts is the rated power or the running power. When you start your AC, before your AC peaks, your AC needs at most 3 times the running power to be able to start up the compressor. So when you are sizing for ACs and you need to switch on all the loads at the time, and you need to calculate your peak load, you need to make sure you include this running power. Use your running power for your peak load. Very, very important. Unless you have it in mind that you're not going to switch on all the loads at the time. Maybe if you want to put on your AC, you can switch off other loads so that you can have space for your AC to run up to times 3 of its running power before it gets back to the 746 watts. The same for your borehole, because these are inductive loads. They have coils and all that, and they're very sensitive loads. They need times 3 of the power to be able to start the motor, then before it gets back to its normal watts, its normal power consumption, 746 watts. I will do a separate video and I will explain how to size for inverters when you have ACs and you have boreholes and all that. Most times you may be needing more than one inverter, so you have to parallel 2 inverters, or in most cases 3 inverters, connect them in parallel, and even your batteries connect in parallel. So we'll talk about that in our next videos. For now, let's just keep it simple. Okay, then for your battery, now you're talking about lithium battery here. Look at this column. You see that the energy, the total amount of energy per day on this column adds up to 5.6 kilowatt hour. It's very simple. Now, lithium batteries, they come in kilowatt hour. We have 5 kilowatt hour, we have 10 kilowatt hour, we have 15 kilowatt hour. Some brands have 16 kilowatt hour, 16 kWh. Then we have 20 kilowatt hour. Then we can also have up to 25 kilowatt hour, 40 kilowatt hour. Now, you can see that from the calculation we have here, if you add up all the energy in watt hour, you have 5.6. So you can approximate, you can round it up to 6 kilowatt hour. Now, this is our energy consumption, daily energy consumption is equal to 6 kilowatt hour. So when you have 6 kilowatt hour, you need to know that you cannot go for 5 because the battery cannot be less than the daily energy consumption that you have. So we need to go for the next available one, which is 10 kilowatt hour. Also, there are some brands that have 8 kilowatt hour. But then again, in case you're looking at adding loads in the future, then so that you have enough extra kilowatt hour to cater for those loads that will be added in the future. So we are going to go for 10 kilowatt hour. Now, there's one thing about lithium batteries you need to know. Lithium batteries, they have depth of discharge. You need to put that into consideration when sizing for solar systems. Now, most lithium batteries, their depth of discharge is about 80%. There are some brands, some good brands that have 90% depth of discharge. That means you have 10 kilowatts, but they will not allow you to use all the 10 kilowatts. They will only give you 8 kilowatts. Some will give you 9 kilowatts. So if you have 10 kilowatts and there's 80% depth of discharge on that battery for that particular brand, it means you can only use 8 kilowatts from that battery. So when you have 8 kilowatts and you want to use 8 kilowatts for 6 kilowatt daily energy consumption, and it is 80% depth of discharge, you know that you'll be having less than 8 kilowatts. It's not be enough. So assuming it's 10 kilowatts we're going for, we have 80% depth of discharge, then we can use 8 kilowatts. Okay, so we are going for 10 kilowatts. Now, what's the backup days? Backup days differ. If you want this system to be able to power all these loads for one day, multiply this 10 kilowatt by 1. That will give you 10 kilowatts hour. But if you want to be able to power these loads for 2 days, multiply 10 kilowatt hour by 2. That will give you 20 kilowatt hour. So let's make things simple. I want one day. So let's see, we have 10 kilowatt hour. So far so good. We've been able to get 5 kVA and 10 kilowatt hour for these loads. I want to be able to power these loads for one day. When the battery is fully charged, this battery can power all these loads for one day at full charge. Now let's go to the panel sizing. That's the last point for today before I round off. All right, now we know to determine the inverter size, which is 5 kVA, and also the battery size, which is 10 kilowatt hour. Then we have the panels left. We don't need to bother about the charge controller because it's a hybrid system. The charge controller is inside the inverter. Now, how do you get the number of panels that is required to charge that battery? Okay, now the rule of thumb for the number of panels is that your panel should be able to generate at least the total amount of energy usage for that day within the required amount of sun time or sun hours. Now, there's what we call sun hours. Now, it differs. It depends on your location. So there are some locations that have just 1 hour of sun for the entire day. Some not even up to 1 hour. Other locations have 8 hours of sun, depending on where you are. So let's use an average of 5 sun hours. Now, the total daily energy consumption is 6 kilowatt hour. So when you divide 6 kilowatt hour by 5 sun hours, you have 1.2 kilowatts. Now, your panel should be able to generate at least 1.2 kilowatts within this amount of sun hours because that's when the sun is at its peak. Now, when you have this, let's just approximate to 2 kilowatts. Normally, hour we cancel hour. So you approximate to 2 kilowatts. You have 2 kilowatts of solar panel array connected together. Now, there's what called days of autonomy. There are some days where you have rain, cloudy days. So you need to also make plans for that as well. So let's assume that the days of autonomy is 2. So you multiply 2 by the 2 kilowatts, you have 4 kilowatts. So your panel array should be able to generate 4 kilowatts at most to be able to charge that battery. Now, it depends on the panel you are using. For this class, and in 2025, you should know that the panel is not supposed to be less than 500 watts and half-cut solar panels because these panels they have higher efficiency. Now, there are those 300 watt panels, their efficiency is very low. Most times, you don't even have up to 200 watts as output from the panels. So you need to use higher panels for you to be able to get enough energy from that panel within the specific sun hours. If you have 500 watts, 600 watts, the efficiency is a bit higher and you can be having up to 480 watts, 450 watts from a panel, from a single unit. So let's divide 4,000 by the wattage of the panel. The panel rating is 500 watts, so we have 8 panels. 40 divided by 5, we have 8 panels of 500 watts. So when you multiply 8 times 5, you have 4,000 watts at most. 4,000 watts of energy from your panels. Now, if you consider losses and everything, let's say highest 3,800 watts, which is not bad. Now, and also, there's one thing you need to know. You can add panels to make sure the battery charging is faster, but you need to know that for hybrid inverters, there's a limit to the amount of panels you can add because they have a specification. For instance, the 5 kVA inverter, the specification is like 400 volts. You need to make sure the total panel voltage does not exceed 500 volts because you are connecting in series most times. So when you connect 8 panels in series, one panel is 48 volts. When you multiply 48 times 8, you have 384 volts. So you need to be very mindful. Make sure it is within the range. 13 amps, the current doesn't change when you connect in series. Then also, the maximum PV power that a hybrid inverter can accept for the 5 kVA is 5,000 watts. And so we're having 4,000 watts, 3,800 watts. So with that, we've come to the end of this class. We've been able to size solar panels, lithium battery, and inverter, hybrid inverter. So you want to do the connection, is very simple. What you do, simply come here. We have 8 panels. This plus, minus, plus, minus. At the end here, we have minus. Just connect all the panels in series, socket to socket, plus to minus, plus to minus. So this plus will come here. This is your hybrid inverter. Now, the hybrid inverter is divided into 2 parts, the PV side and also the inverter side. Now, for the inverter side, we have your inputs, then we have your outputs, then we have the inverter. You connect the positive to the PV positive here. You connect the negative to the PV negative here. Then the inverter's output to your home, to your load, then inputs from the grid to the inverter to charge the battery as well. That is it for this class. If you like the breakdown, if you like how I explained everything here, please make sure you hit the like button, hit the subscribe button, share the video. If you have any question, recommendations, put them in the comment section. I'm there to answer your questions and to attend to your questions. And also let me know where you're watching from so that I'll be able to know where majority of my audience are from. So put in the comment section your location and all that. So I'd like to interact with you in the comment section and let me know the video you want me to do next. So thank you very much, and please stay safe. I appreciate you very much for watching to this time. I'll see you again. Bye.